Hello, good morning, welcome. What is up, Liz? Nice to see you this morning. Let me shuffle these last two around. There we are. Move the microphone a bit and hide myself here. Okay, there we are. Welcome. Happy Tuesday. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. This is a weekly live stream where I work on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website for the project here, circuitpython.org. Basically, CircuitPython is a version of Python that runs on tiny computers called microcontrollers. You can see a bunch of pictures of those over here. When you use CircuitPython with these devices, the way it typically works, you will plug it into your computer with a USB cable. It will show up like a thumb drive. There will be a Python code file on that drive. When you can edit it in whatever text editor you want, and then when you save it, the microcontroller will execute the Python code that is written inside of that file. The code itself can interface with whatever other hardware peripherals you have hooked up to your microcontroller. So some devices are very general. They don't have a lot of stuff hooked up. You can hook up whatever you want. In fact, until you hook some new stuff up, it doesn't really do much. Other devices are more purpose-built with lots of things built in, like these Circuit Playground boards have NeoPixels, are like an educational device, essentially. So it's got a bunch of different, sort of a smattering of different things to play around with and learn. It's got NeoPixels, a speaker, a microphone, buttons, a switch, IR input and output. This one has accelerometer. Yeah, I think that's most of it, although there may be some things I'm forgetting. But there are loads and loads of different ones of these devices, different form factors. They all tend to support slightly different things, like the different form factors will have different peripherals built in, or they'll be made for different connectors or different add-on boards and so on and so forth. So again, circuitpython.org, you can learn more about it. Huge thanks as always to Adafruit. Adafruit is a hardware and software company based out of New York. They make CircuitPython possible by paying a team of folks, including myself, to work on the project. It is open source project. All of the code is published on GitHub under permissive licenses. Anyone's allowed to take it, use it, fork it, change it, do whatever you want with it within that license. And Adafruit pays people to work on it and publish the code in that way. So huge thanks to them for doing that. And if you would like to help support them, one of the easiest ways to do it is by purchasing hardware from them at their website, adafruit.com. I was actually loaded up onto the blog there, but adafruit.com here is where you can buy hardware such as the microcontrollers, lots of the ones we saw on the previous page, also all sorts of other doodads, bits and bobs, what have yous, that you can hook up to your microcontroller to do other stuff with. So jumping in today, I figured I would look briefly at some of the stuff I've been working on, show you all some of that stuff, and then dive in and we can try to fix one of the PRs that I have open. So I will start with this, which is kind of the first project that I'm making, the first guide that I'll make that will use the new capability that I've been working on, which is USB audio for CircuitPython. So here I have a sort of off-the-shelf Morse code keyer. You can push down here and it, I don't know if that, yeah, you can maybe hear that sound coming through the microphone. But it makes a little audible sound itself just by way of the way the design is. You kind of pushing this little brass piece down onto the connector in there, inside here. You can adjust it with these, although I haven't messed with it too much. It has 3.5mm jack here on the end. So there is a 3.5mm cable plugged in, and in this case I have this cable that goes 3.5mm plug here to alligator clips here, and I just have them connected to Circuit Playground Bluefruit, and then the USB cable there is plugging the Bluefruit into my computer. And so what these new USB audio capabilities do This is all about trying out a new camera. I have a new camera set up, and I'm also trying out a new way to show the camera program. So bear with me if I have to fumble a little bit. Maybe we will. It's kind of better up here, isn't it? Because the chats cover it up. Okay. So what this will do is this is a new way that your device can show up over USB. So if we look in BootPi, I'm actually going to do this while I'm thinking about it. Let's undo this and unplug this. That way, yeah, my PyCharm will not be trying to index the files on there all the time. Inside of BootPi, you have to enable this here, just like for MIDI and some of the other USB things, right? So you import USB audio, you enable it. You set your audio configurations. For the most part right now, the main one that you can choose is sample count. You can choose 1600 or you can go higher like 44.1K. Channels has an argument here, but I think right now only one channel is implemented, so 2 will not work there, but it leaves open the door. Eventually maybe we could add support for like stereo sound, for instance. Bits per sample, that's another one. 16, I think, is the one that I have tested most. I don't know if any others work. Maybe 8 with the audio streaming, but I'm not sure. I haven't tried it. But those configure here. Same kind of configurations you would find on like an I2S microphone or speaker. And then here you would put microphone true or speaker true. So right now this is set to microphone true, which makes it so that this Circuit Playground Bluefruit will show up as a USB microphone to the computer. So if I look in Audacity recording devices, listed here is the Circuit Playground Bluefruit USB audio device. So my computer sees that as a microphone. If I go and start recording it, we would hear any of the sounds that it sends back, and what I have it set up for now is to play a tone whenever the Morse code key is pressed. So I'll write up a guide that covers kind of like this setup with the Morse code key, turning it into an actual audible thing, because by itself it's just a switch, right? So using the microcontroller to get the sounds and send those into the computer. And then that is the microphone side of things. And so the core idea here is CircuitPython being able to generate audio and send it into the computer. The computer can then do whatever it wants with it, can record it, can add effects, can do other stuff. You could send it into a stream, you could send it whatever you want to do with it at that point. Into your audio maybe. Audio, what is it? IDE? DAW, Audio Workstation app. Let's see here. And you can use SynthIO. I'll show you the code for this. This just uses a very, very basic SynthIO thing that's got a single key set up that's just pressing it. So we could alter the key that the Morse code thing is using. You can also go more fancy and actual play songs with SynthIO, do whatever you want. And all of that audio, whatever you play into this microphone, whatever you pass into here, any audio that it generates will go through to the PC. This is like most basic example. This is like maybe slightly higher example where it's doing a scale with SynthIO, but still pretty basic. You can also do effects and all sorts of other stuff as well. So that's microphone, and then you can also do speaker, which is basically the opposite. It's the PC sending sound to the CircuitPython device, and the CircuitPython device can then do whatever it wants with it. It can play it through an actual speaker that's connected, an I2S speaker or a PWM out or that kind of thing. It can apply effects to it. It can do all sorts of interesting stuff to it. You could do like audio reactive stuff. So you could make it to where you plug in your microcontroller, it shows up as a speaker. You set up your computer to output, your music to that speaker in addition to your other speakers. And then on your microcontroller, there can be code that does like, FFT or audio reactive stuff where it will break down the audio signal and play a nice animation of NeoPixel lights or whatever you want there. So all kinds of cool stuff with that. I will show you very briefly an example of one of those. So this was USB microphone with the Circuit Playground Bluefruit. I will unplug it for now and swap in the macro pad, which I will show you briefly as well. So on the macro pad, this one actually does both speaker and microphone. Well, I just wrecked it by dragging it with this thing, but when we fix it, this one actually does both. So it is connected as both a speaker and a microphone, or I think maybe headset is technically how the PC sees it, how the computer sees it. But it's like it's able to do both, send audio from the microcontroller to the computer, and receive audio from the computer into the microcontroller, and it can make a round trip as well. So it can receive audio, send it right back out to the USB to the computer by itself. If it's not doing anything, then that's not super useful. You've just made a pass-through that doesn't do anything, but the real fun begins when you start applying effects and stuff in the middle. So you can take input from the USB as a speaker, so the computer will send some sound to the microcontroller. The microcontroller can then apply effects to that sound and then send it back to the computer for the computer to play on the speakers or wherever. So that is basically what this demo is set up to do on the macro pad here. It has these 4 lights on. You can't see these two because I have different caps on it, but there's lights on these 2 slots here. And basically this app is a up to 4 effects digital pedal filter thing, basically. So if I push one of these, it's going to be hard to be able to read it because the text is very small, because the screen's quite small. But I'll try to maybe make out reverb. There's a couple others. Basically, this is a list of different audio effects. So there's a bunch of different core modules in CircuitPython, like audio effects, audio delays, audio speed, audio filters. There's a handful of different ones that exist, and within some of them there's multiple different effects, and this is allowing you to configure those. So I can set up like audio speed, for instance, which is the one I'm on there. I can change the rate either with the knob, and again, I know it's hard to see, but there is the number there on the screen is going up or down as I turn the knob. So we could go faster. You can press enter is the green key down here. You can also use the rest of these keys like a 9-pad essentially to type in a number. So we can go enter, and then now we have the first slot has a filter on it, and you can apply up to 4 filters here, and it is like a pass-through pedal. So it'll take whatever audio it gets, it will apply the filters to it, and then it will send it back out to the computer. Let me see. Let's see here. I will try to demo how it's gonna work. Let's do the CircuitPython parsec.
Character display. So once again, I'm showing.
Okay, so right now we have normal JP. This is just playing through the regular speakers. And what I would do is I essentially need to feed it sort of specially. I have this program which lets me do it. I don't know if this is the easiest way or the best way, but I do know that it is a way. Do we want monitor? I don't think we want monitor, actually. We want... well... capture... it kind of makes a mess of these things here. Hopefully I'm not going to wreck the stream audio, too. That's one thing. I don't want to play around too much with all of the audio things in here, because I don't want to accidentally wreck the stream sound. Have capture and monitor. Where is the output? Weird. I don't know if this rescan affects other programs or not. But I do have it showing up now. The macro pad here is showing up as a playback device as well, and a recording device. So Audacity does see it as both. Oh, it's all the way up here in the corner, and I forgot to check. Okay, so now what we can do is we have JP's audio here. I can delete it so that it's not going to the normal speakers. I can send it to the macro pad instead right here. And then we can take what we get from the macro pad, send that to the normal speakers. Move this back here since it just jumped itself for some unknown reason. All right, so now we go from Firefox into the macro pad, and then we go out of the macro pad into the normal default speakers. And so if I go back here,
this is actually a Shield version, I should say, excuse me. And this one has the RGB backlight. It is plugged into any Arduino-shaped board, Arduino Uno-shaped board, in this case a Metro RP2040. And you can see here I've got some nice little text that is scrolling.
Oh, it's not actually applying it though.
Directions. I'm drawing it to the screen, then I'm sort of slowly scrolling it off screen, and then I'm
disconnected.
A little faster. How does this work, you may ask? Well, I'll tell you. In CircuitPython, I'm importing the Adafruit character LCD library. I'm setting up a
now the Firefox is gone. Okay, so audio, you know, as you can see, when you have a lot going on, especially the stream is not helping because OBS is adding about 100 things to here.
Space CircuitPython parsec space in little text that is scrolling back and forth in two directions. I'm drawing it to the screen, then I'm sort of slowly scrolling it off screen.
And then
there we go.
Screen a little faster. How does this work, you may ask? Well, I'll tell you. In CircuitPython, I'm importing the Adafruit character LCD library. I'm setting up a 16-column and 2-row display here over I2SIn. And then I am creating a little
message here,
which is this.
Okay, so we can turn on and off the channels with the middle row. I can get JP back to normal and back to Chipmunk. And we can also reconfigure so I could change the rate.
I believe it's a 40-character buffer
to write into, and you can have that off screen and bring that back on.
In the main loop, what I'm doing is I'm setting the LCD cursor.
You go down and set it up.
Be the top left corner, 0, 0.
And then I'm printing the message. So simply saying lcd.message writes the message out that first time when you see that come on.
And we can do a bunch of other effects as well. So I'll do one more just for fun.
Move left command. So that doesn't worry about individual characters. That takes the whole message that you've printed. It's on the display buffer, and then moves it to the left. And we are running that at the rate of 0.3 seconds. So that's what gives me this sort of nice moderate speed off.
Okay.
And then on the next loop.
So that shows you the very, very quick version of what it can do. There's a load of different filters in there that you can play with. So it's kind of like just a digital effects pedal for your computer or for anything that uses USB audio. Audio goes in, CircuitPython then applies effects to it, and then audio goes back out, and it comes in and out both over USB. And the effects are with the core modules like audio delays, audio speed, audio effects, all of those things. So very cool stuff. I will maybe pop this one in the guide queue after the more basic one. We'll see. This one I made mostly as just a demonstration and a try to make sure that all the different effects work and that the two-way audio input and output on the same device works. But it actually turned out kind of cool. So maybe we'll guide it up afterwards as well. If it turns out not, then I'll still publish the code. I'll just push it to my GitHub or somewhere. Okay. That is USB audio stuff. The other thing that I got back into recently is I2S audio stuff. So a few weeks back, I worked on I2SIn implementation for CircuitPython so that we could use. Swap in the next one over here. So that we could use I2S microphones, such as this one, which is going to be, again, too hard to actually read the text on because it's so small in the camera here, but it's I2S mic ICS 43434, I think, which is just a cheap I2S mic. Again, you can get that on the Adafruit store. There's a similar sort of microphone on the, what are they? The Sparkle Motion? Yeah, Sparkle Motion devices have a built-in microphone. My original sort of motivation, in fact, for doing this audio I2SIn work was the Sparkle Motions had that microphone. We couldn't use it in CircuitPython, so like the pin wasn't defined, and it was just kind of there as a, like, it's hardware is there, but the software doesn't work with CircuitPython. So I added support for that a couple weeks back, but the support that was there originally is for just record. So you can record from the microphone into memory, just in like a buffer array, or you can record and like sort of write it to the disk as you go, to the flash memory or to a SD card. You can like read a chunk, write it to the flash or the SD, and then read another chunk, read it, write it over and over. And that's basically all the original API could do. It could just record. It was blocking for however long you record, if memory serves, and that's kind of what it was. It mimicked PDM in, which behaves the same way. What I have gone back and done now is implement the streaming protocol, which is what it's called in CircuitPython. All of the audio devices, all the audio APIs that can hook together, that can be sort of linked, not dissimilar to this type of chart, honestly. This one's a bit messy because of the way the wires just run everywhere, but CircuitPython docs, like audio effects, audio delays, audio speed, all of these things. Synth.io, I2S out, audio out, all these things, they can be sort of like chained together. So you can get a source, you can send that source into an effect, you can send the result of that into another effect, another effect, another effect. You can pipe all of those into an audio mixer to change the volume on them, and then at the end of the chain, you can send it to an actual output like a real speaker. So here's an example of that using a Synth.io as the original source, applying an audio filter to the Synth.io source, and then playing the modified audio out of I2S out. And so this new PR here is basically allowing the I2SIn to be the root source of that, so that you can get audio from your microphone, apply effects to it if you want to using the effects chain, and then send it to an output like a speaker, or even back into USB audio land. So I2SIn is technically like a separate thing from USB, like we were talking about a minute ago, but I did make an example that ties the two together. So this is like the code for a very basic USB microphone, essentially, right? An actual physical USB microphone that you could use to have a meeting or do a stream or whatever, right? So this code would take audio from the I2SIn microphone, and then it would just pipe that same audio right back out to the USB microphone to send it to the computer. And then if you wanted to, right in between here, before you call play, you could actually add effects. So you could get the chorus and the reverb and the chipmunk sound and all that kind of stuff. You could put it in the middle, and then you basically have like a voice changer microphone. You can just plug it in, CircuitPython code runs, it shows up as a microphone to the computer. When you talk in it, you get the modified audio going into the computer. So that's pretty cool. One second. Okay. So this is cool. I don't want to try to show it live on the stream because I would need to change my microphone. Well, I'll tell you what. Here's what we can do, actually. Here's what we can do. We can turn this off. So I do actually have some of the effects in this one. Oh. Now we have a feather instead of the macro pad. And let's see. Testing 1, 2, 3, 4. Playback is funky for some reason. Probably should have stuck with just not testing this one on the stream. Does JP still make sound? No, that's broken. I don't want to try to fix it very much because I'm gonna break the stream trying to fix it, I'm pretty sure. Basically, now my PC is not playing audio out correctly. Probably because of the patch thing, this thing. Probably I just need to go in here and either change some of these. Maybe if I close this. Yeah, I don't know. I could try restarting. Probably what I need to do is restart the Pipewire service, but I think that's super likely to wreck my own actual microphone for the stream, and I really don't want to spend any more time troubleshooting audio for the stream. But here is a recording of me saying whatever I said, testing with the effects. I could drop it in the Discord. Y'all could listen to it that way, maybe. Does it play here? No, nothing plays. Nothing with sound plays for me. Probably it will get fixed, like I said, if I just restart my Pipewire thing, but I really don't want to wreck the microphone that is already working. But that's what this other project, or that's what this other audio in thing will do here. So having the streaming protocol here allows that I2S microphone, this one on the breakout right here. I need to be careful actually touching it. Somehow I blew out my other one of these. I have no idea what I did to it, but now it's like, sounds like it's like a mile away when you record from it. So I'm trying not to touch this one in case if it was static or what. I have no idea what I did to wreck it, but yeah, so voice changer microphone there. I think that's very cool as well. But what you may have noticed and what I want to work on actually is the actions are failing, which is because C6 is failing. S3, this one might be size. No. It's expressive. For some reason, some of the expressive boards fail and others don't. Really strangely, some of the expressive S3, like S3 camera failed, but S3 feather didn't, no SRAM didn't, no reverse TFT, regular TFT. A bunch of them passed, but a bunch of them didn't. But it's not, doesn't seem like a space problem either. It's like this thing's not getting compiled or something. So that is what I'm going to try to fix. Let's see. So does it fail for me if I try to build the camera? I could go get my memento. Actually, just put it away before we started, but that's okay. I don't want to copy paste the name so I don't typo. Maybe we will dive in there. The old Claude Code terminal if we need. Ask about anything. I think while that's running locally, hopefully we're going to get the same thing. Wow, this scrolled me all the way up. These are basically undefined reference to audio sample, which is in shared bindings. It's in .o, which I assume means that it's in the .c file first. Nope. Does this exist anywhere? Surely it exists somewhere. An audio core. So that means probably the ones it failed for are the ones where audio core is disabled. So I think what's the deal is that by adding this streaming protocol, we are actually making audio core a dependency of audio I2SIn. And it was not a dependency before when it was only record. Strangely... Oh, okay. I was looking for the red output, but it is the same error. It just doesn't have red. Okay. Probably that is just disabled. That's my guess. Let's try to find out. Audio core. Yeah. Oh, no, that's not that. There's no audio core. So C6 fails the same way. And on that one, we probably just want to disable it. Might not work anyway if it doesn't have I2S. Oh, wait. Oh, this is C6. Why is this also C6? Oh, C6 1. Does this have 1 here? Let's look in the Memento build make thing and see if it turns off something with audio. If it does, then whatever it turns off is the thing that's required. I'm gonna guess that's it. Is there room? What if I tried turning this on for a second? Because it doesn't look like we're... at capacity, really. I don't know which one's the main, like... Yeah, I don't know which one is the main thing or whatever, but... Fortunately, that's in like every file. I was gonna say there's probably... Theoretically, there would be code somewhere checking for audio bus IO and using it to determine, like using it as the condition for whether or not to pull in audio core to the build. If, like, that's the hypothesis here, basically. Hmm. Okay, yeah, that built successfully. And I guess I don't know. Did these benefit from the extra space we gained back when we stopped having space for OTA? Maybe these were at limit. I don't understand which one's the like actual flash, or is the flash a combination of all of these? I don't know how to tell the actual storage space basically from this. Maybe this benefited from that thing though where we had the OTA section, and so we technically had like half, we were using half of the space was reserved, and then we stopped. Maybe when that was the case, there wasn't room for these. Now that it's no longer the case, there is? Hypothesis theory, maybe? That is good, though. This tells us that audio bus I/O is the thing that gates it. So pretty much anywhere where we have audio bus I/O 0, we should also have audio I2SIn at 0. Which in fact here they already were, which is interesting. All right, C6, C61, and I think what was the other one was C2 or something. C2. I've never even messed with one of those. ESP32 C2. Okay. I think that should fix most of the ones that failed. I guess the question would be on the camera. We put that back to disabled and also disable this instead of enabling it. But I think it's worth asking. I'll ask in the PR about the space. So I do have some stuff here that we don't need. So we don't want this. This was me testing stuff. This is also me testing stuff, although I think it would be cool to have these. Yeah, this is one actual caveat I should have said for both of those. Well, for 2 out of the 3 demos I did before, for the macro pad and for the voice changing microphone thing. Both of those are on RP2040 devices, and right now some of these modules are not enabled for that port. So audio delays, audio effects, audio reverb. I think there might even still be some more that I didn't put in this list yet, although I'm not sure. Audio filters, maybe. Some of those were not enabled. I made a custom build with them enabled in order to run on the device with the demo. I think it's just an oversight that they were not enabled, though, so I think we will try to enable them as well. This we don't want in the PR either. This was testing for USB audio stuff on Espressif, which it will need this fix, but it also still does not work even with this fix. So yeah, the USB audio stuff for right now is supported on Raspberry Pi. It is supported on Nordic NRF52840. Also supported on Atmel, but it's not turned on by default because lots of the Atmel devices don't have enough room. But if your device does have enough room, you could definitely make a custom build and it should work. I tested it on Pi Badge, I think, or a Pi Portal, one of the two. I think both at various times, but I don't remember if I might have had to fix something to get it to work. Okay, I tested it successfully on only one of them, but I don't remember for sure. Okay. We do want this, though. So I guess actually we do need this expressive change. We just don't want USB in it. We want only... Should be 3 instances, I thought of. Or was there one? There was one that already had it. There was one that already had it. Okay. Right. Disable audio I2SIn. USB32C6. C61. And Memento. Were there others that failed that aren't C6s? Wait, can't I see the list of them here? I don't know what that is. XT Inc. C3. Might need to do that one too. There is C2. Ah, wait, no. Okay. I'm gonna just disable it. Did it fail the same way? Actually, let's make sure it failed the same way. Because if it did, that tells us that audio core is not there. Okay, yeah. It's weird that it doesn't have audio bus I/O like these did. But I guess this probably covers both. This probably covers both of these. I was thinking of this as like, okay. Yeah, that probably covers both. It's not push. Oh, okay, just didn't refresh here. Okay. So we will see if that passes everything. It looked to me like those were all C6s except for the Memento camera, which we handled, and the XT E-Ink, which is a C3, which now we handled as well. And if there were any other C3s, they will benefit from the same fix because I did it in Expressif makefile. It will probably take too long though. We won't be able to actually tell by the time we're done with the stream. We have about 10 minutes left. If there's any questions or comments or anything on USB audio or I2SIn, now's a good time for those. Otherwise, maybe I will try to just play with this a little more. Very odd that it just doesn't move. It's like the computer knows that it's not successfully sending sound out. Oh, now I have this like region. I didn't mean to do that. I don't know. So I can just do that.
Testing 1, 2, 3.
Oh, did that come out? Did that play?
Testing.
Oh, it does.
1, 2, 3, 4.
So that plays on a different output than I'm used to using. But because of the way OBS is hooked up, y'all should have been able to hear that as well.
Testing 1,
Oh.
2, 3, 4.
There we go. I got it back. Apparently, I just needed to do the old switch back and forth. So yeah, again, that was recorded with the voice changer one. So I2S microphone through the effects chain, and the specific one I think is like speed change, reverb. This one says distortion, but I'm actually just using it as an amp, like the name says. I just use pre-gain to make it louder. I guess technically it's doing a distortion filter. I didn't really, to my ear, this filter didn't really make much of a difference on the actual audio. The main thing this is doing is just the sound. For USB audio in, I've never looked at it before. Are there options for controlling USB audio like mute, mic level, or is it just the stream? Yeah, really good question, actually. Thank you for that. You can do mute for sure. So what would be a good way to demonstrate the mute? Let's just go back to the basics with this one. Okay, let's make one more button. The short answer, though, while I'm doing this, I will say you can mute, essentially. There's an API you can use to just stop, like pause, essentially. I'm not even sure what it's called, so we'll discover together. But there is an API that's like the opposite of play. It will turn play off, which will mute, essentially. It'll make it so that CircuitPython is no longer sending audio to the computer. Volume is not built into the API, but what you can do for volume is you can take your source, you can feed your source into an audio mixer. In this object, and then when you have your source in this object as one of your voices, you can set the volume of that voice, and then you can use the mixer as the thing that you play in the USB microphone. So it effectively will let you control your volume using the audio mixer API. It's just not built in directly to the USB thing. Yeah, for the play, I need to know the buttons. So let's just use button A. So I think you should be able to toggle it even, because I think you could do if mic.playing, mic.stop or pause or something. Let's look. stop. Go stop. And then let's make sure there is a playing. I'm pretty sure, yeah, playing is a Boolean. So, oh, there's actually a pause as well. It says remembering the position. We don't really have, there's not, I mean, if you're playing a file or something, but then you could just stop playing the file. The position doesn't really make a whole lot of sense here, but you can actually, it looks like, just use pause and resume as well. So, well, but then you would need to know, oh, okay, there's paused actually. So you could go if mic paused, mic.play, in this case, synth, right? Yeah. Synth, else, mic.pause. And then I think you don't need to pass anything to that one. Or pause, and then resume. So this is actually not play, but just resume. Digital in and out has no fill. Button A debounce, this should be. Okay. Need to rescan. Oh, I turned off this. Oh, we can't do it while it's running. Okay. It's not doing short presses very well. Huh. Interesting. I wonder if that's spamming. No. Okay. Well, in any case, it doesn't matter too much that it is not doing the short ones right now. I'll fix that. It's not making super great contact or something. Okay, so now that's running and it's playing sound normally. We should be able to press... Oh, that is counting as A pressed. Huh. Maybe those buttons need to be not pull-ups. Do those need to be pull-downs? And or did I just mix the buttons together? I mixed the buttons together. So I have a button and a debouncer. So yeah, it was... That is exactly what broke it, is it was muting as it was playing, essentially. The play button was the mute button. There we go. Now it sounds normal. And if I press the A button, whichever one that is... Nope. Just kidding. They do potentially need to be a pull down, then, is my guess. Okay, there we go. So I pressed A, and it's muted now. You can potentially hear me tapping away on the Morse code thing, but we're not getting any tones. If I press A again, I can show you the camera as well. Press A again. It'll unmute. And now we can do that. I did notice just there, the when you resume, it makes a little blip. So maybe instead of pause and resume, play and stop might be better. I'm not sure. Because like I said, the keeping track of the position doesn't make as much sense for like a live streaming thing. There's not really a position other than the current time. But yeah, so pause and resume works. Play and stop might be better to get rid of that blip, but I'm not sure. I haven't tested them difference. And then audio mixer for the volume. Totally you can do. Okay. That is going to do it for the stream this morning. Thank you to everyone for watching. As far as I know, the plan is Scott's returning this week, I think, later in the week. As far as I know, I think he's planning to deep dive on Friday, so I think he'll be there. And I should be back probably next Tuesday, and then I think I'll pick up on my weekend streams on Saturdays, not this weekend, but the next one. So I'll take one more week off. But then I think I should be back on Saturday mornings, 10 a.m. Central Time, over on my channel as well. And as always, I'll be here on Tuesdays, 10 a.m. Central Time, 11 a.m. Eastern, 8 a.m. Pacific on the Adafruit channel here for Deep Dive on Tuesdays. Remember that later today, you can check out JP's Product Pick of the Week, 4 p.m. Eastern, 1 p.m. Pacific. There will be a live stream here on the same channels that you are watching me on. JP will be here, and you will be able to get a fabulous discount on whatever the chosen product is. As always, thanks to everyone who watches. Thanks to everyone who supports CircuitPython and the other open source work that Adafruit funds by buying hardware from them. So long, farewell, and I will see you next time.